This video is about intersecting lines and circles, whether they intersect in two places, whether they intersect at just one point, so we have a tangent, or whether they don't intersect at all. So we're going to do three examples, one of each. First one is this one. Just to make the video a bit shorter, I've already shown all my working out here, but I'll explain it. The question wants us to find the coordinates where the line y equals x plus 5 meets the circle x squared plus y minus 2 squared equals 29. So we're working out where they meet, so the x and the y coordinates are the same. So I've done simultaneous equations to begin with. I've substituted the x plus 5 in instead of the y here. So here's the x plus 5 where the y was in that equation of the circle. Now just to simplify that a little bit, the 5 minus the 2 is 3. Then my next step is I expanded this bracket to get the x squared plus 6x plus 9. Then I've done the x squared plus x squared is 2x squared. I've got the 6x and the 6x is there. And then I subtracted the 29 from both sides to make this equal to 0. So the 9, take away the 29 is minus 20. Then, to solve this quadratic, I noticed that I could divide all of these terms by 2. So the 2x squared became x squared, the 6x became 3x, the minus 20 became minus 10. I factorised, and I found then that x is either minus 5 or x is 2. I've then taken those values and substituted them back into the original expression here to work out the y values. So if I substitute minus 5 here, y is minus 5 plus 5, which is 0. If x is 2 here, I get 2 plus 5, which is 7. So the 2 points where that line intersects that circle is minus 5, 0, and 2, 7. Just to show that on a graph so you can visualize it, here's the circle in blue, there's a straight line in red, and you can see they intersect at the point 2, 7 there, and at the coordinate minus 5, 0 there. Second example, we needed to show that the line y minus x plus 7 equals 0 does not meet the circle x squared plus y squared plus 3x plus 4y minus 5 equals 0. Now, you can see I've started this question in exactly the same way as the previous one, in that I'm assuming that they do meet to begin with. So I've started to do some simultaneous equations. I've rearranged this to make y the subject. So I added the x and subtracted the 7 from both sides. You could have made x the subject if you wanted to. It doesn't really matter in this example. Then what I've done is I've substituted the x minus 7 into the y here and the y here. And that gave this line here. I've then expanded this bracket. I've expanded this bracket. And then I've collected up some like terms. I've got the x squared and the x squared is 2x squared. I've got the minus 14x plus 3x plus 4x, which is minus 7x. And then I've got the 49 minus 28 minus 5, which is 16. Now, we've got this quadratic, 2x squared minus 7x plus 16. If I could solve this equation, it would give me the x coordinates where they intersect. But remember, I need to show they do not intersect, which means that this equation here should not have any solutions. And if a quadratic doesn't have any solutions, then its discriminant should be negative. So let's check that. Let's work out the discriminant for this equation. The b is minus 7. The a is 2. And the c is 16. So 49 minus 4 times 2 times 16 is 128. And 49 minus 128 is minus 79, which is less than 0. So I can then say, therefore, no real roots. And if this equation has no real roots, then the line and the circle do not intersect. So therefore, line and circle do not meet. So if I need to show that lines do not meet, I will pretend that they do to begin with by doing simultaneous equations, and then show that that leads to no answers. So they can't intersect. And you can see here, here's the circle in green, and you can see the straight line down there in red. You can see that these two lines do not intersect. Third example for the video says we need to find the values of k such that the straight line y equals 2x plus k is a tangent to the circle x squared plus y squared is equal to 25. So we can see that we know the gradient of this line is 2, but we don't know what its y-intercept is. We need to work out what the y-intercept is going to be if it's a tangent. Here is all of my working out that I'm going to talk you through. So, I've started off in exactly the same way as I did the previous questions by doing simultaneous equations to work out where the straight line meets the circle. So I've substituted my y into the circle there. That's given me this. Next, I've expanded this bracket. The 2x squared is 4x squared. The 2x times k is 2kx, but then double that, so 4kx. And the k squared is there. Next, I collected up the like terms. I've got the 5x squared. I've got the 4kx. And then I've got the k squared, and I've subtracted 25 so that it equals 0. Now, focusing on this quadratic equation here. This quadratic equation is telling me where those points, where the line intersects the circle. But I know there should only be one repeated solution to that because it's a tangent. So if there's only one repeated solution to this equation, that means its discriminant is equal to 0. So just to repeat that logic, the tangent means they have only one repeated solution. If you have a look here, we'll get to this diagram in a minute, but you can see that the straight line just touches the circle once. It doesn't go through in two different places like that. It just touches once, which means that its discriminant will equal 0 for one repeated solution. The b of this equation is the 4k. The a is 5. And the c is the k squared minus 25. Then I've expanded these brackets, so the 4k times 4k is 16k squared. The minus 20 times the k squared is the minus 20k squared. The minus 20 times the minus 25 is positive 500. I've then collected up these two terms to give me the minus 4k squared. Then I divided both sides by minus 4 to make it a bit simpler. Added the 125 and then did the square root to find that k was either positive 5 root 5 or negative 5 root 5. And just to show that on our diagram, I've got the circle. X squared plus y squared is equal to 25. I've got my line here with a gradient of 2 where the y-intercept k is 5 root 5. And you can see that is a tangent to the circle. Or it could have been that k was minus 5 root 5, which is down here. That's where the y-intercept down there is minus 5 root 5, where again we have another line with a gradient of 2, where it is a tangent to the circle. So those are the two values of k that mean that 2x plus k is a tangent to the circle x squared plus y squared is 25.